This week is going to have the same basic structure of previous weeks. First, we're going to learn a mechanism that supports interactive programs. That mechanism is called Big Bang, and no surprise, there's kind of a bad pun involved in the name of Big Bang. We'll talk about that later. So first, we're going to learn that mechanism, and then later in the week, we'll start learning how to design with it. To explain the Big Bang mechanism, what I'm going to do is I'm going to start by looking at a couple example interactive programs and just kind of reason from first principles about what has to be going on inside those programs, the inherent structure of those programs. Then I'll explain how Big Bang works and how it supports that structure. So imagine that we have two fairly boring interactive programs. So the one on the left is just counting down 8, 7, 6, 5, 4, and so on. And the one on the right just has a cat walking very slowly across the screen. And I'm going to say these programs are interactive because if I press the space key, they both reset back to the beginning and start running again. So that's the sense in which they're interactive. These two programs have classical interactive behavior. Some underlying state is changing, the number in the countdown or the position of the cat. There's a changing image on the screen, and pressing the key does something, or perhaps clicking the mouse might do something. So there's two simple interactive programs. Now let's think about what's going on behind the scenes, starting with the countdown program. There's the current number in the countdown, which is the middle column of this table. It starts at 10 and then it goes to 9 and so on. And there's the currently displayed image, which is the image of the number 10, the image of the number 9, and so on. And what's happening is that once a second, n gets decreased by 1, and the image gets updated to be the image corresponding to the current n. So there's kind of this behavior of the clock ticking tick, 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 and each time n and the image are both updated. Now if we look at the cat program, the same kind of thing just inherently has to be going on inside of it. In this case, the changing state is the cat's x position. It starts at 0, and then it goes to 3, and then it goes to 6. The idea is that the cat's moving 3 units per tick. And in this case, the image is an image of a cat at that position, rather than an image of the numeral. And in this case, the ticks are also counting up, 0, 1, 2, 3, 4, but they're counting much faster in this case. Let's just say for now they're ticking 28 times per second. Whereas in the countdown program, we wanted it to tick 1 time per second. Now continuing with this exercise of thinking about what just has to inherently be inside this program, let's think in terms of information and data for a second. We've got these numbers 0, 3, 6 that are representing the x position of the cat. So when we do something like that, what we use is a data definition. We use a data definition to tell us how we're going to represent domain information using data. So here's a data definition for that. We're going to say that cat is a number, and we're going to interpret that number to be the x-coordinate of a cat. And the rest of this data definition is fairly straightforward now. It's simple atomic data.